Okay. Thanks, John. Again, we're showing some of the techniques for how to handle these micromilling machines and how to cut the parts the most efficient way, and attacking them the way that it has to be attacked to get the results that you want. This one here, this is just a couple of examples. This is a handy lathe machine. It's an actual lathe, and you can see the size of it. The next one was like a manufacturing work cell. John? John? Oh, there you go. This is a desktop factory where it's doing several different operations all on this little table here. So this whole market is definitely growing, and there's a tremendous amount of opportunity in this market, and quite a bit of an investigation has to go into what you're looking for and what you want to result. So at this time, we're pretty much open for any questions. Again, just type in the question and we'll address the questions.
All right. Thank you very much, Ralph and John. If you do have any questions, please send them in, and we will be logging off shortly. But if something comes to mind, we encourage you to email to Ralph directly, and he promises to get back to you. All right.
Here's one question that came through: is how long have we been supporting the micromilling technology? I want to say 3 or 4 years. We've been supporting this. We saw a tremendous opportunity, and we started development for the very tight tolerances in the tool control.
There's another question.
All right. There's another question: is how is tool wear accommodated for?
I think with the monitoring systems out there, again, I'm not an expert on the tools, on the machine side and the monitoring system. I think the monitoring system is monitoring the load of the tool. Also, there's some opportunities when creating these tool paths that, after so long we can go and re-inspect the tool with the laser and see if it's still within tolerance and then continue cutting, rather than cutting the whole job and finding out that, at the end it wore out. So, there's several different options to monitor the tool wear. And a lot depends on the machine manufacturer.
Okay. Another question: is the angle of determination between level cutting and lacing user definable?
Yes. Yeah, it's what we call slope control. You can define what you want as defining as based on an angle from horizontal. So from 0 to 30 degrees, you want to call that horizontal, and anything above 30 degrees, you want to call it vertical. You can specify that. And the software automatically takes into consideration the overlap, and so it doesn't just start in the next level down. It's starting at the same level that it left off at. So.
Okay. Another question for you, Ralph. There was a question pertaining to the use of coolant during micro cutting. Is it used?
Again, it depends on the type of material. Most of the stuff that I've seen that they've, when cutting, usually it's just air.
Okay. All right.
Again, I'm not an expert on that. I can definitely check with our micromilling partners and get you some answers on that as well too.
Okay. One of the questions had to do with the Cimatron seats. The question is, do we have micromilling with our seats at Cimatron, or do we need something additional?
No, it's all part of the It's all part of the NT program. It's not anything that's extra. It's, it's an upgrade that I believe came out in version 8.
Okay. Another question is, how is Cimatron handling the point distribution differently for the micro milling compared to standard milling?
Well, again, the new algorithms for the micro milling are, calculating the tool path at a much, much tighter tolerance. So we're laying down a tremendous amount of points rather than standard conventional, programs. Like John was showing on that spiral cut. A 2/10 tolerance doesn't sound like much, but you could definitely see where, when you're at a 2/10 tolerance, you're plus or minus 2/10 from the actual surface. So it's going to put a lot less points around that, diameter than, when you're using the micro milling.
Okay. There was a question about plunge cutting. Is this possible? Is it doable? Plunge cutting doable in the micro arena?
Yes, I believe so. But again, it depends on the type of tool. It's I don't know. You definitely can do it. It depends on the type of material you're cutting and the tool that you're actually cutting with. It seems like every week they're coming out with new varieties and new coatings for these tools. I'm sure it's doable. I don't know exactly. Again, I'll check with our micro milling partners and have them get me an answer, and I'll respond to everybody.
Okay. There's a question about ultra short pulse lasers. Do you have experience working with ultra short pulse lasers, which can ablate material in very fine increments? If so, what are your observations, pros and cons of using a laser?
I'm not familiar with that at all, but I'll investigate that and see what I can find out and pass the information along.
Okay. There was a question here regarding general feeds and cutting speeds. What is achievable with micro milling?
Again, it varies. I'd have to talk to each individual machine manufacturer is going to be different. Again, it depends on, the material and the tooling that you're using. I'll definitely find that information out too.
Okay. How do you set machining parameters? Tool manufacturers, by tooling manufacturing recommendations, or did you develop them yourself through trial and error?
What was the first part of that question?
How do you go about setting machining parameters? Do you rely on tooling manufacturer recommendations, or did you develop them yourself through trial and error?
Yeah, it's definitely you're starting off with the tool manufacturer, their recommendations, but then it's you're going to rely on experience as well too in testing. There's tremendous amount of testing to achieve the results that you want. In some cases we tried cutting it 4 or 5 different ways to hold the less than 1 micron tolerance that they were holding and the surface finish. So one tool you may want to cut it in a Z-level fashion, where another tool you want to maybe cut it in a lace or an upward only manner. So again, yeah, you'll have to work with from the tool manufacturer as far as their recommendations, but I would say that's a starting point. we're not going to come out of the box with recommendations on, for a 3,000 diameter, tapered cutter, and you're cutting, stainless steel. You should be cutting this way. A lot of the micro-milling manufacturers have done a lot of testing and have that information, and they'll be able to help you as well too with the right tooling and the feeds and speeds. But once you get that information, you can store that information in our tool library. So every time you're going to use that tool, you're going to be using those feeds and speeds and side steps and down steps. So there's no, next time you go to use it, I have to re-punch it all in. But we're keeping all of that with our tool library. The plunging and the side feed or the entry feed into the part. You may want to slow down a little bit, or if you want to break out, you're breaking out of the stock. We have all different options to store that information. Once you have the most and the best efficient way of using that tool, it's stored right within that tool. So you don't, every time you use that, you have the right settings.
All right, we have a question here. What are the minimum hardware requirements to run the software?
The minimum requirements, we'll run pretty much on any PC that you can go out there and buy today. Again, it's more of how many, surfaces or how many, how large the parts. We're seeing some electrodes. We ran across electrodes that had 160,000 faces. Well, in that case, you're definitely going to want something that's pretty powerful to calculate. So, PCs are getting cheaper and cheaper. RAM is cheaper. I would say the very minimum requirements probably 2 gig of RAM and basically any of the PCs that you have out there. The graphics is important as well too. Our software, we support NVIDIA graphics cards. You don't need the high end. We support the low end ones. So it can be a couple $100 for a graphics card. But today, pretty much any PC is efficient enough to run the software.
Okay. Ralph, there's a question. Can the software tell you how many linear inches have been traveled for a specific tool and or tool path?
Yeah, we can. We do track that. We also have an option that if you only want to cut for 30 minutes, or if you only want to cut for a certain distance with the tool, then we can put that in there in our tool library as the tool life, and it will intelligently go and change the tool, not right in the middle of a cut, but it'll go and intelligently change the tool and grab the next tool. So yeah, we can monitor that as we're cutting and switch tools, or we can tell you what the total length of cut is.
All right, there was a question about the demonstration part. What was the total machining time for the gear programs, roughing through finish, and what was the material being machined?
John, are you still on?
Yeah, I'm still on. I actually didn't run a report on the length of time. I can get back to that person with that information. When I'm done, I can find out exactly what it was and get back to them.
All right, thank you. All right, we're running short on time here, and what we would like to do is remind you that the presentation has been recorded. You will be emailed a link to the recorded version, which will allow you to listen to any portion you have missed or would like to hear again. And remind you that if you have further questions, you can send those to Ralph. We'll have a slide here that shows where you can send those questions. And again, this is Don Nelson, speaking for both Cimatron Technologies and MICROmanufacturing magazine. I want to thank you for your time and for participating in today's webinar.